A ball is thrown from the field with an initial speed 4.5 meter per second and elevation angle of 60 degrees. Due to the gravity, the ball moves with a parabolic trajectory. When the ball reaches the top of its trajectory, what is its velocity in meter per second? The gravitational acceleration is g equals to 10 meter per second square, neglecting the effect of air resistance. Okay. So first we have initial speed u and elevation angles of theta, and then we have to find the final velocity at the top of path. We need to draw the diagram of motion. The ball moves in the path of projectile motion, and here we have initial velocity with an angle of theta or 60 degrees to the horizontal, and we have to find the velocity on the top of path. The initial velocity 4.5 meter per second has the component of x-axis and y-axis. We can determine the component of x-axis 4.5 meter per second times cos of 60 degrees equals to 2.25 meter per second, and the y component is 4.5 times sin 60 degrees equals to 3.89 meter per second. And the ball keep moves on the path until it reaches highest position. The vertical component will be decreases until 0 at the highest point, but the horizontal component remains constant. So at the highest point we only have the horizontal component of 2.25 meter per second. So the total velocity v equals to vx equals to 2.25 meter per second. Here we have the diagram of waves traveling at x-axis. The figure is a snapshot graph at t equals to 0 second of a 5.0 Hz wave traveling to the right. The wave displacement for this wave in International Standard Unit is. We have the general equation of waves, which is y equals to a. We can use sin or cos, and omega t plus minus kx. So we have to find first the amplitude is 2 meter, and then we can use cos because the graph shows cosinus pattern, and then we have to find the omega or radial speed equals to 2 pi times frequency equals to 2 pi times 5 equals to 10 pi. And then we have to determine the k equals to 2 pi over lambda, 2 pi over, okay, so the lambda can be determined by this point until this point. So the lambda is equals to 2 meter. So k equals to pi. Now we can determine the equation. Y equals to 2. We use cosinus and 10 pi. Since the wave travels to the right, so we use minus. K is pi x. So this is the wave equations. An object of mass 0.25 kg is placed on top of a light vertical spring With the spring constant of 5,000 Newton per meter and pushed downward so that the spring is compressed by 0.10 meter. After the block is released from rest, it travels upward and then leaves the spring. What is the speed of the object at the height of 5 meter above the point of release? Use the gravitational acceleration of 10 meter per second squared. So first of all, don't forget to write the symbol of each quantities. And I think we need to draw the diagram of motion. Here we have the spring, and above the spring we place the mass. So the mass will push the spring until it compresses by 0.1 meter. At this point, we have potential energy of spring. And then we release the mass so the object can move upwards. The potential energy of spring changed to kinetic energy of spring, and then until the object reaches the height of 5 meter, the kinetic energy will be decreased and turns to gravitational potential energy. So we have two kinetic energy. First is kinetic energy maximum, and the second one is decreases of kinetic energy. Remember that we have to find the speed at this point. So we can use the conservation of energy. First, potential energy of spring will be equals to kinetic energy maximum. And then kinetic energy maximum will be equals to kinetic energy at point 5 meter plus gravitational potential energy at 5 meter. We can find the speed or the final speed from KE. So KE max equals to half mv squared plus mgh. And we have to find the speed. Here we don't have KE max yet, so we have to find the KE max by potential energy of spring half K delta x squared. So KE max equals to half times 5,000 times 0.1 square. KE max will be equals to 25. Let's substitute the KE max to the next step. 25 equals to half. The mass is 0.25 times v squared plus 0.25 times 10 times 5. 25 equals to 0.125 v squared plus this one will be equals to 12.5, and then 25 minus 12.5 equals to 0.125 v squared. 12.5 equals to 0.125 v squared. So v squared equals to 12.5 over 0.125 equals to 100. So v equals to root of 100 equals to 10 meter per second. A ball of mass 1 kilogram is dropped from a height h equals to 4 meter above the floor and immediately bounces straight back up. If the heat generated due to the collision is 10 joules, how high does the ball rebound. So first we have to draw the diagram of motion. The ball is falls down. At the highest point, the ball have gravitational potential energy, and it changed to kinetic energy and changed to heat. So the ball bounced back up at lower height. So we have the second gravitational potential energy. We have to find the height of the ball. So we can find the height from GPE2, and we can use the conservation of energy to solve this problem. The maximum energy is GPE1, gravitational potential energy 1. It changed to heat and gravitational potential energy 2. So we can use mgh equals to heat plus mgh2. 1 times 10 times 4 equals to 10 joules plus 1 times 10 times h2. 40 equals to 10 plus 10 h2. 30 equals to 10 h2. h2 equals to 30 divided by 10. So h2 equals to 3 meter.